Okay, next let's look at cut, and cut does everything that bin code does, right, and it does more. Okay. So if you remove bin code and put cut here, it will work. Okay. So let's say I take that, okay, and use cut, then it will work. Except now look at what cut does. Cut doesn't code like 1, 2, 3. What it does is that it gives you the range for each value. So again, the square bracket means it's inclusive. Okay, the regular parenthesis means it's not inclusive. Okay. And you can use labels here. Labels equal to, see here, how many bins do we have? Now there are 4 breakpoints and we have 3 bins. Okay, so we can say that. All right. So it will give you the labels instead of the range. Okay. Then cut also gives you an option to say, all right, I want equal width bins. Okay, right? Equal width bins. So then we can do cut df to weight, and then just give a number, say 4. Then it will get divided into 4. So we can also say labels equal to, okay, A, B, C, D, and Mr. comma there, and then it will give you this will be equal width bins. Okay. And suppose we want to bin equal frequency bins. Okay. If you want equal frequency bins, then we have to create the breaks in such a way that the number of observations within each break is about the same. You're not going to get absolutely right because sometimes the numbers don't divide equally. So we can use what is called quantile. Quantile, what it does is, okay, it takes the data frame. So here it is df to weight. Okay, so let me do it here. Okay, so quantile. Okay, and we want to cut this. Give probabilities now. Probs equal to, then if you say 0, 0.5 and 1, so then what you will get is breakpoints for the weight. Okay, so it's going to be equal one range, half the observations, second range, the rest of the observations. Okay. Okay, so that should be 0, 1. Okay, sorry. So it should be 0, comma 1, okay, 0 to 1, and then how many bins you want. That's what the probability should be. No, that's not right. Probability should be 0.5. One should work. Probs equal to C, I think. All right. So now it gives you the cutoff points 1.513 to 3.325. That will give you 50%, and then 3.325 to 5.424. That will give you the rest of it. Okay. So once you have, you capture those breakpoints and then supply it in cut. So that will give you. So to make this more general, suppose we say n bin. All right. So we want, say, 6 bins. All right. Now we want to take the value 0 to 1 and split it into 1 over. We want the probabilities to be 1616161616, right? So what we can do is we can give it a sequence going from 0 to 1, 0 to, in increments of sequence function. We have seen this before, is starting value, ending value, and then the step value. So starting is 0, ending is 1, and the step is 1 over n bin. And that will split it into 6. You will have 7 breakpoints giving you 6 bins. Okay. So what we need to do is to capture those breakpoints into a variable. All right. And then we do cut df to weight, right? And then we have what is called breaks equal to BR. Okay. So now what we need to do is to do include. So include lowest equal to true. So everything gets included. Remember, right is true by default. It's the left side that we have to worry about. Okay. Then that's going to create our equal size, the equal frequency bins. So if you do a table of this, we can check it out. Okay. So here are the bins, and you see that it's 6, 5, 5, 5, and 6. Okay. Remember, you're not going to get perfectly exactly. You can't get 5, 5, 5, 5 everywhere, 6, 6, 6, 6 everywhere, because the number of observations is not evenly dividing into 6 bins. Okay. But if you don't like this as your labels, you can always add the labels. Okay. So if you want to add labels here, you can do this. Labs equal to, okay. So if you take break BR, well, let me do it this way. So BR, let's see what BR is. Okay. So BR gives you this. So all right, so if you change this to as character BR, so now you get the breakpoints as character. You can probably use around 2. Well, I need Okay. And you really don't want all of it. So now you can use this, you can drop the last one out because you want, this is the lowest, there are 7 numbers, there are only 6 bins. So you can then say, all right, I want as character BR, we want only, we don't want the last one. Okay, we don't want the last one, so which means we can say length BR. So that will get rid of the last one. You can capture this as labs, all right, and then put labels not table, so it should be here, labels equal to labs, then we have it. So let's put that in here. Okay. So you use cut. Cut gives you a lot more flexibility. Okay. You can have any cut points you want, break points you want. You can say how equal width bins, and if you want equal frequency bins, then you have to use quantile and set up your breakpoints and use those breakpoints for binning.